Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning. Okay, so in this video, I would like to help you on question number 1 in your tutorial. I think I would like to focus on how to determine case by case when you do graphical method of convolution integral, and then the second one is that I would like to focus on how you want to set the limit of your integration, and then the third one is that I want to show you in terms of how to do multiplication, okay, of two signal during the multiplication process step. Okay, so take a look at the question over here. So you are given a LTI system where the input of your LTI system is given with this signal over here. And then after that, you are given the impulse response of the system, which is ht equal to 2, ut minus 1 minus ut minus 2. And then you need to determine output of your system, which is yt. As we know, for LTI system, the output of your system is equal to xt convolution convolved with your impulse response of system, which is ht. So you have yt equal to xt convolved with your ht. Okay, so first, okay, to solve this, okay, so we need to draw both signal over here. So you are given xt over here, and then remember that this straight line of xt over here is equal to t. Okay, and then for your impulse response of your system, okay, when you draw it, you will get a rectangular signal over here with amplitude of 2 because you multiply with 2 over there. Okay, and then after that, you need to compare which of these two signal is much more complex, because we need to determine which one of the signal will be a static signal and another one will be the moving signal. If you compare these two signal, so we know already that xt is much more complex. So compared to our ht over here, so we have this graph t over here. So because of that, our xt will become a static signal, okay, and then our ht will become the moving signal. Okay, it will become the moving signal. So because of that, okay, so our equation will be like this one. So we have xt convolved with ht, where we know over here we want to have our xt as the static signal, and then ht will be the moving signal. Okay, all right. So after this, what we need to do is that we need to change the domain, okay, the time domain into the tau domain for both graph. So for xt over here, we change to x tau, and then this graph also you need to change because you change t to tau, so t and then change to tau, right? And then change the axis, the x-axis over here into tau, right? And then same goes to our impulse response of the system, which is ht, and then we need to change to h tau. So you have now this is the signal after you change from t to tau. Okay, and then after that you need to inverse the moving signal, which is h tau over here. So we need to inverse h tau, and then when we inverse this, so we will get this graph. Okay, so you inverse it like you fold this signal based on this y-axis over here, so we will get this graph over here, right? So you do not need to do anything with the static signal, because static now we just focusing on the moving signal. So after step 2, which is inverse the moving signal, so we will do step 3, where we shift by t the inverse moving signal. So when shifting by t, so we add t into h minus tau over there. So this will become this one, and then this one will become minus 1 plus t minus 2 plus t. Okay, so we'll be interested on this point and this point. Okay, because this is the transition, and then this one 0, 0, and 2. Okay, so we're focusing on these two point over here. So after we shift by t the inverse moving signal, so we will multiply both signal over here. So you will get, when you multiply these two signals, you will get x tau equal to ht minus tau. Okay, if you look over here, this one. So we have x tau ht minus tau. So after you multiply this, of course you will do the integration, and then we need to determine the limit of your integration. Okay, alright? Okay. So let's do the next step, which is the multiplication process. Okay, so multiplication process. So first, in this process, which is step number 4, so first we will divide the static signal into section based on the graph over here. So for example over here, x tau, which is the static signal. Okay, so the first section will be when x tau equal to 0 over here. This is the first section. And then the second section will be when x tau equal to tau. This is section number 2. And then when x tau equal to 1 will be our section number 3. And then the next one, when x tau equal to 0, will be our section number 4. And then after that for the second part is that of course we will do a multiplication process, top and bottom method over here. But to determine the cases much easier, so we need to combine both graph over here. So we combine our x tau and our ht minus tau together. Okay, alright. And then after that we determine the case, and then we determine the integration limit, and then after that we do multiplication process before we integrate. We do the integration process. Okay, let's do case number 1. Of course, we know that our moving signal will move from negative infinity, and then t is keep increasing. Okay, and then after that it will go to until positive infinity over here. So for the first cases is here. So we just concentrating on the multiplication process. We concentrating on the section over here. So the first case will be when your signal over here, this signal, just be in the first section. So this one is the first section. Okay, until it reach this point. Okay, until it reach this point, and then it cross to the second section, or section number 2. Okay, so the first cases when the graph only inside your section number 1. Okay, so this one only happen when your graph is touching tau equal to 0 at this point. So when tau equal to 0, your signal will be in your section number 1. Okay, so you look over here. So if you look over here, you have minus 1 plus t. So your value of tau, this one must be equal to tau equal to 0. Okay, before it go to section number 2 over here. So we don't want to have that. For case number 1, only when this graph be in section number 1. So in order to do that, okay, we need to determine the t over here that gives you tau equal to 0. So what is t over here that gives you tau equal to zeros? So when you move here, so when you have tau equal to zeros, when you have 1 minus 1 plus t equal to 0. So that's the reason over here you have uh, minus 1 plus t equal to 0 because tau equal to zeros over here. So what value of t that gives you tau equal to zeros? Okay, t equal to 1. So that means when you have t equal to 1 and below, okay, t is less than 1, so this signal will be in section 1, which is our case number 1. Alright, so this is case number 1. So since when you multiply 2 with zeros, you will have zeros, and then integration of zeros, so you will get 0. So that is the reason you have yt equal to zeros, and then this one only valid when t less than 1. Okay, because of you want to make sure that your signal over here will inside your section number 1 only. Right? That's case number 1. And then for case number 2, of course, you know, it keep moving. And then this one's case number 1, and then it keep moving. And then you have right now part of the signal is in section 1, and then another part of your signal is in section 2. So combination of section 1 and section 2 will be your case number 2. Okay, so if you look over here, so you have part of it number 1, and then part of it number 2 will be your case. You will be your case 2. Okay, so when you have the signal cover 2 section over here, so you only have over here only happen, okay, when you have your minus 1t minus 1 plus t equal to 1 only, or your tau value equal to 1. And then this one, after that it become will be in section number 2. Okay, so there are no half of it, part of it is section number 1 and part of the section number 2. So these cases only happen until your minus 1 plus t when tau equal to 1. That's the reason why you have minus 1 plus t equal to 1. And then what value of t? That will give you tau equal to 1. So t equal to 2 over here. Right? So you have case number 1 previously, and then which is t less than 1. So of course t is more than 1 because it keep moving, but must be less than 2 over here. So when you multiply these two graphs together, so you have 2 multiply with tau over here. So you have 2 tau. And then, of course, over here you have zeros. Okay, when you multiply these 2 equal to 0, will be zeros. And then 2 multiplied by tau will be 2 tau. Only start at tau equal to zeros until minus 1 plus t. So that's the reason you will get this 0. Minus 1 plus t, valid only t less than 1, then t more than 1, and then less than 2. Alright, so based on this graph, okay, so we will determine our limit of our integration. So it will start from 0 until minus 1 plus 4. Right? Okay. Okay, let's do case number 3 over here. So case number 3 is that when you have part of it in section number 2, part of it is section number 3. Alright, because it keep moving. Previously case number 1 number 1 is here, case number 2 over here, and then now we have case number 3 over here, which is part of it is number 2, and then part of it is number 3. Okay, so if you look over here, so this is only valid where you have part of it number 2 and 3 only valid when you have until this point. So when your minus 1 plus t reach tau equal to 2. And then after that, it will change. Okay. Yeah, it's not part of it number 2 and part of it number 3. It will be the next case over here. So for case number 3, part of it is now in section 2, part of it in section 3. This one only valid until you have minus 1t plus 2t equal to 2. Because you have 2 minus 1t equal to 2. Okay, which value of t that give you t equal to 2? So you can calculate this and then you get t equal to 3. Okay, so we have t more than 2. Okay, and then t must be less than 3 for case number 3 over here. Okay, so if you look over here in terms of when you multiply both signal, 2, first part is that 2 plus tau. So this one, the first part, okay, in section 2, 2 tau. And then the next part will be this one. Okay, 2 multiply with 1, you will get 2. Okay, and then the rest will be 0 over here. So if you look over here, so this one will be 0 also. So you only have negative 2 plus t, negative 2 plus t, 1 minus 1 plus t over here. So your integration, okay, will become like this. Okay, this one first part and then second part. Okay, first part which is in section 2 and then this one is in section 3. Okay, for the first part, you have negative 2 plus t which is 2 tau d tau and then the limit will be negative 2 plus t until 1. And then for section 3 part which is in section 3, you have 1 until negative 1 plus t 2 d tau. And then you can do your calculation, okay, over here for integration. Okay, this one is case number 3. Okay, when part of it is in section 2 and then part of it in section 3. Alright. Okay, case number 4, when and then as you know that this signal keep moving and then part of it is part number in section 3 and then part of it is section number 4. This will be our case number 4. So this case only valid, okay, until you have over here, if you look over here, negative 2 plus t reach 2. And then after that, over here, it will be different. Where all of the signal in section number 4. So over here, part of it is section number 3 and then part of it is section number 4. So this one only valid when you have negative 2 plus t equal to 2 over here. Okay, so what value of is t value that give you tau equal to 2? So you need to calculate that. You have minus 2 plus t equal to 2 and then t equal to 4. So this case number 4 only valid when you have t more than 3 and then t must be less than 4. Okay, so this one. So when you multiply this, okay, look carefully over here. When you multiply this, okay, so this one will be 0. 0 multiply 0 will be zeros. And then also same goes to here. And also goes to part of section 4 over here. When 2 multiply with 0, you will get 0. Okay, so the remaining is that this part, okay, which is part of section 3 over here. So part which is in section 3, 2 minus 1. So you will get 2. This one is start from negative 2 plus 4 until 2. Okay, because this one becomes 0, so you have only until 2. That's the reason that the multiplication of these two signal is equal to 2. And then this will be start from negative 2 plus t until 2. Right? So the integration will be negative 2. I think this one wrong. It should be negative 2 plus t over here. And then until 2. And then 2 tau. Not 2 tau will be 2 d tau based on this one. Alright. Okay. Alright. This one case number 2. Number 4. Okay. Case number 4. Okay. And then after that is keep moving. The signal keep moving. Okay. So this will be case number 5. where all of the signal is in section 4 over here. So this one only valid when you have when this one pass to 2. Okay, that means so you have tau more than 2. So you have negative 2 plus t is more than 2, and then t equal to 4. So you have t more than 2 over here. More t equal to 4. So you have t is more than 4. So you have 2 multiplied with 0, you have zeros, and then the rest will be 0 multiplied with anything over here. Signal xt over extra over here will be zeros. So everything is 0. So you have yt equal to zeros. This one only valid when your t is more than 4. Okay. So this is the whole cases over here. So this one a bit wrong over here. So I just make the changes over here. So you plus t, and then this one will be deleted. Okay. So you have integration of minus 2 plus t to 2. Okay, you integrate 2 d tau over here. So this is the whole thing. So you have case number 1, case number 2, case number 3, case number 4, and case number 5. Okay, remember? Okay. So for moving signal, it will move from negative infinity to infinity. Okay, so before that, you need to divide your static signal into section over here based on the signal. And then the moving signal will move from negative infinity to infinity. And then you determine cases by cases based on this section, whether you have full inside this section or half of it in the section. All right. And so on over here. Hopefully you understand how to determine case by case in graphical method of convolution integral. And then the next one is that you understand how to do the multiplication process of those two signal over here to come up with this graph and this graph over here, and also the limit of your integration, okay, over here, which is based on the graph of multiplication of these two signal over here. Right? Hopefully you understand how the whole process of convolution integral, especially how to determine cases by cases. The second one is how to determine the limit of your integration, and then how you want to do multiplication process of those two signal. Okay, all right. So hopefully you understand. Okay, and then see you in the next video. Thank you.